What's up? Welcome back. Today we are working kind of on my Git GUI. So context here is I want a GUI that has some set of features that I don't feel like exists in the world right now. And so I have this like Git GUI, and one of like the many things that it does is it shows, well, I shouldn't say many things. Basically, the only relevant thing that it does is it shows what changed in a given commit, right? So I can click on this commit and I see like, let's look at something like a little bit more useful. And it says like, oh, here I'm like limiting the memory usage. And how do I do that? Well, here is all of the changes that I made for that. And the interesting part at this point in time is, hold on, is that there's like move tracking of some form. So like here I can see like, hey, I took this chunk of code over here and this came from a different place in the same file. And I can see that by hovering over the thing. Great. Wonderful. And what we're working on today is trying to fix the fact that the diff algorithm that we're using is like pretty expensive in terms of memory. So if I look at like, if I say, hey, don't use more than 10 megabytes for the algorithm, it's starting to say like, hey, I can't generate a diff for this file because it's over the maximum of 100 megabytes, or sorry, 10 megabytes, and I required 32 megabytes of RAM to generate a diff for this file. And it's like, it's not very big, right? If I look at libdiff source librs, you know, say ls-l libdiff source and look at librs, this is only like 50K file, so 30 megabytes is like kind of insane. And the memory usage scales with number of lines, not size of the file, which is a little bit confusing. But this is like, you know, it's a pretty big file, right? 1,600 lines, but really it's too much. And we get into the case where sometimes we have a file in our working directory. Our Git GUI shows like the index, and he shows like untracked files in here. And so if you have like a big file that's ended up in there, you can try to allocate like 360 gigs of RAM, a terabyte of RAM, like whatever. And it's just like, fuck, that sucks. And so we've kind of like mitigated this with this like memory limit, which is great, but it would be better if we could actually generate diffs for that stuff. So that's kind of what we're working towards. We're using this diff algorithm. If you just Google like diff algorithm, you come across this guy's blog, Myers diff. Let's see, this guy. And he kind of explains like, okay, so there was this paper written by Myers in like the fucking 70s or something. Like it's like a really old paper. Let's see if we can find it. Myers diff algo Wikipedia. Surely they will tell us when it came out. Like yeah, the 70s of some form. Anyways, point is, he represents this like problem of trying to find the best edit sequence as like a 2D grid, a 2D graph. And so here, let's see, diff viz. Let's kind of show. So we've been writing like this like visualizer that shows us like, okay, say we have a source string one, it's kind of hard to see there. 1, 2, 3, 4, 5, 6, 7, 8, and you're trying to get to the destination 3, 4, 6, 6, 5, 1, 2, 9. You can kind of like represent this problem as a graph, and at the basically what happens is you have like rightwards moves indicate like that you're traversing the source string in some way without traversing the destination string, which kind of the only like concept that can map to is a deletion, right? You're like, okay, so I have like this source string and I want to move along it without touching the destination string. That's a deletion. And in the same vein, like if you walk vertically along this graph, you're kind of saying like, okay, I'm like moving forward on the destination string, but I'm not touching the source string, so that's like an addition. And then you draw diagonals in these cases where the source and destination run into the same spot. So here we have like, you know, 3, 3 is a diagonal because it's like the same destination. 4, 4. Here we have like 6, 6, 6, 6 again. And the idea is we basically just do a breadth first search. So if what we've been working on is this like algorithm, this like visualization where you can say like, okay, I'm going to step through this guy, and you can see he goes here, then he goes down here, then here, then here. And then here what happens is he says, oh, there's a fucking diagonal. So I'm going to like jump down to the bottom of this. And then he keeps going, kind of like greedily jumping down diagonals as they come. Great. And so if I like spam the next button a few more times, we can kind of see like, okay, so the path to get here is like delete 1, delete 2, keep some stuff, delete 5, keep some stuff, delete 7, delete 8, and then keep the rest. That's like what the diff is going to produce for this. And the expensive part of this algorithm is the backtracking. So in order to get to the end, when we get to the end, we have to say, okay, we figured out the fastest path, right? We did a breadth first search. But now how did we get here? And so as you're doing the breadth first search, you're basically keeping all of the nodes in the graph that you went through as like part of your tracking. And then when you get to the end, you just say, okay, well, this is the one I looked at, so I'll just walk backwards to see how I got there. And so as this graph gets bigger and bigger and bigger, that takes more and more and more memory. Gross, boom, too much memory, boom, explosion, program crashes, whatever. Okay, so what is the linear version of this? The linear version of this says there is a forgetful version of this algorithm. So if I run this with forgetful, that's a term that like we made up. But basically here, we do the same set of moves, but we're only ever remembering the last place in the graph that we looked at. So here, the memory usage is much, much, much lower, but you only know you only know which node you came from just now. So you can still figure out, like, you still walk the path that is the best path, you just don't remember how you got there. But here's where the trick comes in. If you do that same walk, but you do it in both directions, from like the top left and the bottom right, so like here and here, at some point the backwards and the forwards walk are going to collide with each other. And when they collide, you now know that you've got some path that you could like bisect the problem with. So if we imagine that the two paths collided like here at this node, this is like x1, 2, 3, 4, 0, 1, 2, 3, 4, 5, and y2, we could actually then bisect the problem. So we could say, we are going to limit this guy, so we're going to say, right is at, what would you say, 5, and bottom is at 2, I think we said? Nope. Right, 1, 2, 3, 4, 5, bottom. I think that there's a bug in this parsing, surely. So, okay, for now, we'll take a look at this in a second, but let's pretend that we like bisected this problem now. And now we can run the expensive version on this like subset of the graph, and we've kind of cut out, like, if you imagine that you drew another box down in the bottom corner here, then you've kind of cut out all of this stuff, and you have like a lot of memory. So the idea is you just basically do this over and over again, breaking the problem into smaller and smaller chunks, until you're at the point where you can do it with a small amount of memory. And so like the reason they call it linear is because eventually if you do this enough times, you only need enough memory. You can break this problem down so that each box is representing one move, and then you only need as many pieces of memory as there are boxes. But what we'll probably do is we're probably going to set like some sane memory limit, and then just continuously squish down until we are within that memory limit. That's probably what we'll do, but we'll see. We will see. And yeah, so what we have right now is, other than this like kind of bug where we're parsing these things wrong, we have the mechanism to both do the forgetful walk and the mechanism to break the problem into smaller pieces. So the last thing we have to do is we have to be able to walk backwards. We only have to walk backwards with the forgetful version. And then once we get there, then we can like look into like, okay, figuring out how to find where they meet and then stitch it all together. So that's the plan for today. That's the plan for today. But I guess before we do that, let's fix bug in box slicing. So here we expected this thing to be a lot less vertically tall, and I think it's probably just we are fucking up our argument parsing in our diff visualizer. So here we have this bottom guy, field bottom is never read. We have like a big warning on here, so it's very, very fucking clear that that's the mistake. And just somewhere we say bottom is equals args.right, and we just say bottom here. Oops. Oops, oops, oops. So let's try that again. We draw the box. Yeah, and now it's drawing where we expect. And it's limiting the same way we expect, so nothing to worry about. I was only concerned that if it was a bug in like the actual algorithm, that would suck. But it's not. It's fine. Okay, so I'm not even going to bother writing that down because it's useless. It was like 3 seconds. Okay, so let's figure out how to implement backwards iteration. Okay, so the way we represent this problem is kind of just yoinked from the paper, which is also /yoinked from the blog post. And they represent this as, let's see. So we have this like 2D grid, right? And you can imagine that the horizontal and vertical positions on the grid are X and Y, right? So like any normal fucking graph that any human has looked at, right? X goes right, Y goes up and down. And they say, okay, there's like a more efficient representation of this space when we're doing this like breadth first search, and it's with variables D and K. So D is like how many, this is D0, D1, D2, D3. Right? So it's like how far are you from like the sort, like how many steps have you taken essentially? Right? 0, 1, 2, 3, 4. And they use the second variable K, which is like which diagonal are we on? So you can kind of imagine that if you were to draw like a diagonal line, well, we don't have to imagine. We could screenshot this and pull it up in Paint, and we could draw them. So let's do this. We will export into Color Paint. Womp. And my fucking Color Paint is broken, and I have to figure out how to fix it eventually, but I'm not going to right now. So you can kind of imagine that you draw like, oops, let's draw a fucking straight line here. So you can imagine you draw like a diagonal line here. Fuck me, dude. Lines are... Maybe we use the line tool. I want it to be thicker. Right? So, like, you can imagine you draw a line here. And this is, like, no straight... Like, if you were to imagine, like, the optimal path, the two files are the same. This is the optimal path. So this is, like, K0. Then they draw a line here. K is -1. A line here. K is 1. Here, K is -2. K is 2. And so there's like this conversion where now you can kind of just walk these diagonal lines. And so they work in like dk space. So the diagonals are K, the kind of like distance along those diagonals is D. And so there's this like little loop, and he says, well, for K and -D to D, we look at each node and we say which one's better, prefer deletes, prefer diagonals, and then just like rip through diagonals if you see them. So that's kind of like the source material that we're working with. Our version looks a little different because we kind of had to take it out of like a loop and stick it in a state machine so that we could visualize it easily in our representation, like in our graph, so that like when I click the next button, we can like extract the state at any given point. But that's essentially like the root of what we're doing, is like this step function in our algorithm is essentially doing the same thing, right? He's saying like where... convert my dk position to my xy position, and if I see that there are diagonals here, if I can walk the diagonal, just like increment those guys, and then otherwise somewhere he does a non-diagonal move. Right, I mean the non-diagonal move is assumed by dk, right? And then he stores in his like what he's writing down as he goes is basically like what for each given dk position. So say I'm like here, what x position do I have here? And the idea is that well, like when you hit a diagonal, the x position is going to increase faster for a given dk, and then you can convert that back. Okay, great. So now what do we have to do? We have to, we are iterating from, I want to pull open this again. And so we're iterating from like the top left to the bottom right. And what that represents is what? X-axis forwards along one string, Y-axis forwards around another. So I suspect that to go from the bottom right to the top left, we could probably do it with very little code change if we just swapped the x and y axes here and reversed the order of the, like, iterated backwards. Right? So you just say, you could maybe, like, package up these arrays in a way where you could index them the same way, and the algorithm could do the same thing, but we'd like, how do I say this? But we could like abstract away the backwardsness, maybe. Let's look at that. Let's think about that. So here we take inputs, which are like source string A and B, and or so sorry, I shouldn't say string. Source A and B. Where they're kind of broken up into lines in the case of our Git GUI, but in the case of our like visualization, they're just like a list of numbers. Anything that's like equality comparable. And then we say here, let's look at these arrays. Okay. We have a k value, so we can imagine a case where these source and destination, if this diagonal didn't like, if one string is longer than the other, this diagonal won't make it to the end point won't be on k0. So we probably have to store some sort of like k offset when we're iterating backwards for like the conversion the other way. Maybe? Maybe not. We'll see. Okay. So I wonder, like, maybe we just let's just start by trying to iterate these things backwards and seeing what that looks like. So maybe in our algorithm thing, we just store direction. And we will say that we have some direction associated with this. And we'll just say it's forwards or backwards. And in all of our existing code paths, we're just going to say that we're going forwards. But maybe we'll say we'll make like a function that will generate a new backwards version. And so he is going to say this guy is going to take in backward or direction. So here he's going to use the direction here. These guys are all going to have to say which direction they were currently going. So this guy's direction forwards. This guy's also forwards. And then this new guy is going to be backwards. He's going to pass in the box, and I think we're going to, for now, in the future, we're going to use the forgetful version for the backwards iteration. But let's use the memory, like the one who's smart for now, who remembers the whole world. Just so that when we visualize, it'll be easier to understand. And we'll come back for this later. So now we have a direction. We have a direction. And if we're going backwards, we're going to have to maybe store some sort of k offset. I guess we'll see how it goes. So he is going to say, I have my d number of steps taken, I think is fair. We can just keep using the number of steps taken as self d. Self k, I think for now, we'll just keep as is, and we might have to adjust it later when we have to like correlate the forwards and backwards passes together. But if we're not worrying about correlating them, then the k value is like an arbitrary number. But we do have to find a way to convert our k to an x and y, which represent like how far into each of a and b we're at. So maybe we have like some function, maybe it goes in the algo. That doesn't need public. He's gonna have some function x. He already has a function x. Great. So he takes in k and returns an x value. And so is this the same? How does this work? He is storing the x value in the trace. And so I guess where is this guy used? He's used in order to walk. He's used in order to walk the inputs, like the sources, and used to index them, and used to increment along diagonals. Okay, so here's kind of like an assumption here that x will be incrementing. And so maybe all we do here is we adjust these guys. this seems to be the only place where he actually looks at the input data. So we could do something like let index extract from A. There's going to be some like closure, and he's going to take in an index. And we can do something like match match self direction. And depending on the direction, we can like return a different closure. I wonder if that makes sense. I'm trying to think like maybe I'm getting ahead of myself. I was kind of thinking that if we're doing this in a loop, it sucks to have to if our like direction every time when it's kind of like a known thing. But maybe that's getting ahead of myself. We should implement something that makes sense first, and then look at the profiler and optimize later if we need to. And I imagine we won't need to be honest. So let's say let extract from A is equal to some index. Is equal to some closure that takes an index. And maybe we'll call this xpos to be clear. We'll match our direction. And if we're going forwards, we just look at a x as usize. Yep. And direction backwards is going to be a a.len minus x as usize. Is that correct? -1 as well? Yeah, I think there's an extra -1 in there, because if x is 0, a.len is out of bounds, so we have to subtract by 1. And this is going to return some sort of reference to a u. And so here we need to borrow, I guess. Yeah, and this guy has to be an I64. Okay. And maybe we'll call this extract from source, and we will call this position. Yeah. And we will also pass in the source. This. And I think we are chilling. And then this guy becomes a source as like this. I think that makes sense. And so now we can just say extract from source xa is equal to extract from source yb. And I think nothing should change there. They don't like that we can't debug print the direction, so we'll just drive debug on this guy. Debug. And he doesn't like some reference bullshit? Wait, what's the problem here? Are these like, maybe this needs to be like a function. Maybe the closureness is pissing it off. Because this should be fine. So we will just make this a real function somewhere. Somewhere down here, maybe. And here, I guess we have to pass in the direction as well now. Direction. And U needs to be a template parameter now. And is he happy now? Extract from source. Oh, we're missing the argument now, so these guys both need self direction now as parameters. Plump, plump. And this guy needs to implement copy so that he knows he can copy him out. Okay, that's working now. Okay, So now if we run our tests, I think nothing should have changed because all of our tests should be constructing this guy in forwards mode, but they're not working. Oh, I fixed this bug off stream yesterday and forgot to pull it in. This was just an off by one error. In hold on. It was our early stop on the backwards pass when we resolve our string. This was a less than or equal to, and he should have been a less than. And then when we construct this guy with our debug info, we needed to adjust his limit. Sorry, I forgot to do this. I thought I fixed this. Okay. Now all of our tests are passing, so we're chilling. That means that like this abstraction here is working okay. And now we can try running it backwards and see what happens. Except these... Oh yeah, I think everything might work. So we can try in our diff viz main, we'll add an argument to run it backwards. So backwards. Oopsies. This guy is backwards. Args now needs a backwards like this. And then wherever we construct our diff algo, we'll say if args backwards, else if args forgetful, and we'll say new backwards. Yep. And then I guess technically we should check if backwards and forgetful, we could just say here panic backward forgetful cannot be set in backwards mode. We'll just say fuck you, whoever's trying to call you, and I guess it shouldn't panic. You should return an error string like this. Yeah. Cool. Okay, so now we should be able to say run backwards. And let's just fucking see what happens. Okay, so I think that what's happening is it's actually running backwards, but we're rendering it like it's running forwards. Because like, well, yeah. Because here you can see this diagonal is probably this diagonal here. And yeah, this diagonal is this diagonal. So we are running it backwards. It's just rendering forwards. So I think that's in the debug info thing. We need to correctly extract. So here we kind of have to say, well, we're gonna run through our backwards iteration. But for each of these guys, we're gonna check the mode. So we're gonna say, match. Sorry, I have to think. So we're gonna say let local to global XY or something. I don't know. Local, yeah, that's fine. That's a okay name. It's not a great name, but it's an okay name. And this is gonna take in XY as a tuple, and he's gonna do what we were doing here before. Right? He's gonna say this, but then he's also gonna say we have to be careful about the order of operations in terms of like moving from backwards to forward space and box to unbox space. I think it's probably going to be backwards to forwards first, then box to unbox. So we're gonna say that we're gonna look at like self dot. Oh, interesting. We need to know the lengths of the arrays in order to invert the direction here, which means that we need to kind of like write those down somewhere. Or we can just pass in A and B here, which I think is fine. A, U, B, U, and U is anything. I don't give a fuck. Okay, so x is equal to a dot len minus x minus 1, and b, or y is b dot len minus y minus 1. And then here we should just be able to say map using local to global xy, like this. These guys have to be as S4. And now when we call debug info, we just have to pass in the A and B. So here we'll just say self.a and self.b. I think it's like this. And let's see how that works. We're close. We're close. It's the -1 is wrong here because the xy is 1 larger than the data. Okay. I think that looks right to me. I think that's right. Let's look again. So what we should be seeing is it should be favoring moving left over moving down, which is what's happening. We should be seeing that when it hits a diagonal, it immediately jumps up it, which happened here. Happened here. Yeah, I think that's working. Pretty sure. And I guess we can also... Oh, wait, hold on. I think we're favoring the wrong way. Because we should be seeing that it should take the same path that it takes in the forwards pass, and it's not. The forwards pass is going right here, not down here. So we actually have to invert which guy he prefers. Which is probably in the step function. He's supposed... Somewhere we say, I prefer going right. Right. Because we swapped the direction, but we didn't swap A and B. Yes. So A and B actually have to be inverted in this case. So we say actually let A, B is equal to match self direction. And if we're going forwards, it's going to be what we have here. Actually, let's leave this. No, okay. So this is going to be A and B, like this. And if we're going backwards, it's just we're going to swap them. So I guess it's kind of more like we limit them to the boxes, and then we say if it's forwards, we get A, B, and if it's backwards, we just go BA. And we don't need like these squiggle braces. Sorry, what are they called? Brackets? Brackets? Braces. Braces. Brackets, braces, and parentheses. So we just swap them. And then what? Then I guess X and Y are related to the wrong thing. So when we get our debug info, I'm concerned that the backwards iteration here is using... It's almost like we want to go YX here. Or local to global XY. I guess here we swap them. So like this. And then here we need to say like new x, new y, and new x, new y. I'm like really unsure about this. Like very much so. It feels like like the top, bottom, left, and right need to get like maybe swapped because x and y are now referring to different things. Which kind of is making me think that this whole strategy feels wrong. We should keep x and y meaning x and y. That's probably simpler. And then we just need to make sure that whoever is favored here he probably has to invert this condition or something. Let's think about this. So what is he doing here? He is storing the farthest x position for a given diagonal. And here he's preferring, he says if left is lower than right, where left is I moved from, yeah, here he's saying if I move from the left, take the left, otherwise go, sorry, so left, god damn it. God damn it. So in the forwards mode, let's look at the forwards mode. Fuck. Why is he going backwards? I didn't say backwards. Did I fuck everything up? Extract from source. We should be going forwards. And in our debug info, nothing here has changed. What the fuck is going on? If args backwards, args forgetful. Like, we should be here. Normal. Right? Like, here you should say we're going the normal way. So what the fuck is going on here? That's fucked. So it must be in our debug info extraction. He must be doing something fucking stupid, but I don't see anything fucking stupid. I don't see, am I high? Get diff? What do we change? Backwards, 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 backwards. Okay, nothing crazy in there. Blah, blah, blah. Oh, I'm fucking stupid. This is just, I don't know why. I looked at that like 4 times and I'm like, it seems right. It's obviously not right. Obviously not right. Obviously not right. That's only in the backwards pass. Okay. Boom, boom, boom. Okay, so for each k value, let's say here, what I'm saying is there's this option and this option. And he's saying if left has a lower x index than right, we pick the right one. So here, his left is here, which is a lower x index. So he's saying pick the one with the greater right index, okay? Otherwise, pick left plus 1. So otherwise, he's incrementing x. I see. And so in the backwards version, he should be saying right plus 1 to go. No, in the backwards version, his x position is staying the same. Aha. Aha, aha, aha. Okay, yeah. So here we should be saying match self-direction. And we're going to say direction forwards, he returns left plus 1. But if he's going backwards, we go pick left. And that way, the x position stays the same, which means the y position kind of like implicitly increases. And I think that's probably it. And then we have to fix that thing that we just commented out in the debug info. So this guy has to say, we're going to make x and y mutable here, and we're going to say match self direction. And if it's direction for, or I guess we say forwards, we do nothing. But if it's backwards, we have to invert x and y. So it's like that. I guess. So let's make sure that the forwards version is still sane, blah, 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 nothing crazy. We have to remember the path is basically as high up as we can go. And so now let's run it backwards and see what we see. Okay, so there's a good sign there where we can see him favoring moving up. Right, so that's a really good sign. And now we have to wait till we hit a diagonal. Something here is just obviously wrong. That was not right. So here, we actually wanted to pick... We actually wanted to favor moving up instead of taking the diagonal? Does that make any sense? If we want the lines to line up, that is what has to happen. Is that what this guy did? And was this what this guy said? What did he say we do? Divide and conquer, blah, blah, blah. Okay, this is, I want his implementation. So here his forwards pass is normal. Backwards, what's the difference? So he's walking backwards with the x and y, great. How does he pick here? So he's saying k plus 1, c plus 1, else k minus 1, c minus 1, x is equal to px plus 1. Oh, so he's storing y positions in the backwards version instead of x positions. But x and y are like equivalent in this world if I understand correctly. Are they? So we have like this k diagonal. Yeah, so given any diagonal, there is exactly one xy pair. So that should be fine. That should be fine. And so far, actually, in this case, it looks okay. When there's no diagonals, it's fine. It's when we hit a diagonal, it does something fucking stupid. And in reality, this is like what I would expect from the algorithm. Like does he say that we should be? Does he say that the diagonal? What am I trying to figure out? I don't know what I'm trying to figure out. Does he say that we're supposed to like lazily look for the diagonal? It seems like that's what makes sense to me. That like we actually we have to prefer to go up here. But then like here we have to know to take the diagonal, which is confusing because you would only know that. You would only know that if you went the whole way up. So surely surely this is just a downside of this algorithm. Okay. So here something fucked up happened. Something fucked up. So here we're going diagonal, diagonal, diagonal. Diagonal, hold on. Something's wrong here. 1, 2, 3, 4, 5. Bum. Okay, so far so good. Here he moves. Great. And then here we're looking at this position here. Comes from here, he moves up here. I'm going to turn my head to make this make sense. Okay, I want to store this so that I can look at it in a second. For comparison purposes. Okay. So this, he is trying to come from above, but really he should be coming from below. That's the bug here. That's the bug. Which means probably our like X position resolution is wrong. Well, he's supposed to say, I can either come from right or down. And now he's coming from up. So, hold on. I think it's a bug in our backwards iteration. Because I think that is actually technically the right X position for that node. He's just struggling to understand where the previous one came from. So here this is like a previous Y, previous X thing, get previous K. And here, probably the iteration direction matters. Yes. I wonder if we need to like invert the K values when we're doing it backwards. Does that make this make more sense? I wonder, it might. No, it should. Let's think. Maybe. Because this left and right invert if the K values are inverted. Which kind of sounds like what we actually wanted originally. Maybe. We could try it and see what happens. Why the fuck not? So let's undo this and we'll say left plus 1 will stay. Left plus 1 is where it'll be. We'll leave that X extraction the way it was. And then we'll just say when we no, surely iteration order doesn't matter here, right? That's ridiculous. Ridiculous. But maybe this K equals negative K. And then here we use negative K. No, nothing about this. This does not sound right. This sounds really wrong. This feels wrong. But we can see. There's no way. It just fucking crashes. Yeah, of course. God, it's so complicated. It's so complicated. So I think we'll go back to the other way of thinking about this. The forwards pass is working fine. And And just when we get the previous k value, we have to depend on the direction. Which is a direction. And then we just have to do whatever we were doing backwards when we extracted the x value. Or when we calculated the x value before, which is Jesus. If left is less than right, so it's in this match direction. And we just have to do the opposite thing if we're going backwards. It must be. That must be it. What do I know? But it must be. So this guy now needs to pass in self-direction, which is not being stored. So here we have to say direction is a direction. Which means here we need to pass in a direction. And I'm not really... There's pieces of this that I feel like are now getting, like, overcomplicated. But we're going to leave it this way for now and then figure it out later. Just because I want to know. Because once we have a feel for how all of the different variables play together, then we can work on simplifying, and it should be a lot simpler once we understand. But right now we don't know where this like has to propagate, so we're in like exploration mode. Here we'll just use direction forwards unconditionally. Okay, so let's look at that again. Okay, so this is working fine. Blump, blump, blump. Okay. Yep. This is not right. Here. What the fuck? Yeah, what the fuck is this? That, I feel like, should never happen. What is that? This is turning out to be... I thought this would be straightforwards. I feel like I'm just losing my mind. Okay, what is happening here? So here he's looking at a dk value. So let's d0, d1, d2, 3, 4, 5. 1, 2, 3. How does this work again? It's this diagonal, this diagonal, this diagonal, and then we skip this diagonal. So we should be seeing that this guy comes from here. Yeah, okay. So I guess this is what I want to save a screenshot of. To compare. And then this is the problem. So here, what did we want to happen? We expected we've gone down this diagonal, yep, and then we expect to go down the next diagonal, which is this one. And he should have to say, oh, hold on. Does that diagonal just not exist? Is that the problem? This one, this one, this one. Yeah, he has no k value to like. it has to be done here. What am I missing? This. Yeah, okay. So when we're going forwards, does that not happen? Like this. Yeah, okay. I see. Something's fucked up here where, like, we're on the wrong diagonal now. How did that happen? I guess this guy should have gone left. It feels like he has to go left in order for this algorithm to work. So favoring upwards movement was like wrong. In which case, what we had like originally, where it was going left first and then just taking a different path, where it was going like whatever, it went like this or something instead of like this. Maybe that's just like correct. Could be. Let's. Maybe I need to read this a little more closely. Or maybe we'll look at the original paper. Linear space refinement. Symmetric with respect to. The problem is symmetric with respect to the orientation of the edit graph edges. So he's talking about the shortest edit sequence. Not talking about the actual diff, just the number of removals and additions. Consider reversing the direction of every edge in the edit graph for sequence AP. So blah, blah, blah. They're still modeled as paths in the reverse edit graph, but now paths start at NM and end at 0, 0. Yep. This interpretive path alters just slightly to reflect the reversal of direction. Each diagonal edge beginning in XY gives a symbol AX equals BY, and the comment blah, blah, blah. Each horizontal edge responds to a delete command, etc. So the LCS problem can be solved by starting at NM and progressively extending furthest, reaching past the edit graph until one reaches 0. Hereafter, forward paths will refer to those in the edit graph, and the reverse paths will refer to those in the reverse edit graph. Since paths in the opposing directions are in exact correspondence, the direction of the path is distinguished only when it is of operational importance. So this is where I'm missing something. D path, D plus 1 snakes, blah, blah, blah. Divide step, finds blah, blah, blah. So I'm missing some like inversion of the graph that makes it so that this path is the same. Because I don't understand how we get to here when we're going backwards. Because you kind of have to favor, you'd have to like go up, left, but no set of rules would result in that. I guess what would, if we had like this. Yes, that's it. We need to trend up first, but then have like leftward branching down things. So what we did before was we went left then up, but we need to go up then left. That's okay. I think we're getting somewhere. Up then left. Up then left. Up then left. Okay, so that's going to be in the forwards walk. Our X position he is going to... I wonder if it's like something like these have to be inverted. Okay. So if k is equal to self-negative d. God damn it. Coordinates are so hard. Coordinate systems are so hard. My head, it hurts. It's in so much pain. Okay, so mapping of dk to x, y in forwards is just trace the x value stored. Storing x values in trace backwards means that a upwards move is no change in x. Vertical moves are always no change in x for a given k change. Okay. So I wonder if it's like this one also has to be this. So this is going to be this. Like the +1 is only related to the forwards pass. Backwards is... It could be. Because that's what we did on the other side, and that made sense when we figured it. That's what we did down here, and that made sense to us? To me? to someone? Let's see what happens if we do it this way. We crash. Great. Where are we crashing? Because I think that probably the backwards pass is not correct anymore. So this is at 417. So that's here. So in the forwards pass, we're crashing because y is not greater than or equal to 0. So that doesn't sound right. Left is k minus 1, and so here we're saying go... Fuck me, man. So this is what? We are... This condition is like, hey, we are at like the highest k value. The most rightmost thing. And so here we're saying if we're the highest k value, we have to transition horizontally. And then we're here, if we do it, what we just did, we're saying, nuh-uh. If we are at the highest d value, we have to transition vertically. I think that still makes sense to me. Here, if we're saying we're at the lowest k value, we have to transition horizontally. So this also needs to be in here. But this is going to say k plus 1 instead of k minus 1. Okay. Let's see if that changes anything. We probably will still crash. I'm not really convinced that it'll fix anything. Yeah, that still crashes. And so let's look at line 419 here and just kind of see what values we're getting. So we can say print line dkxy. So self.d, self.k, self.x, self.y. Oh, this is not self-dot. This is just x and y like this. Oi, oi, oi. Okay. x0, y1. Great. And here we got x0, y negative 1, where we should have got x1, y0. So there's a mistake on which branch we're taking somewhere. And we can kind of look at that. So this is d is 1, k is 1. Okay, so that's the case where k is equal to d. we are going backwards. And so he picked... Oh, okay. So in this case... vertical is... Oh, our D... Let's look at this again. D1, K, -1. So we're doing... negative is actually... like, up and to the right. And positive is down and to the left. So when we go down and to the left, no matter if we're going forwards or backwards, we need to increase our x position. So this seems like it should stay like this. Just by, like, slowly reasoning this out. Because that's how it was in forwards before. Forwards isn't changing. Backwards, I'm pretty sure that's what we want. Okay. And then here, the problem is we wanted this to be horizontal. So why is that not happening? Here. So here we had D2K0. So that's the normal case. X1, Y1, great. And that's all fine. Aha. Nope. So this is about the backtracking, I guess. His x value, let's like double check this again. So here his x value sure is the right thing. His x value is 1 here, and his y value is 1, but the path is wrong. But like that's fine. We'll ignore that for now. Let's look for a place where he hits a diagonal. Okay. So this diagonal, this diagonal, this diagonal, this diagonal. Yeah, it does seem like kind of on this diagonal, he's right to say that this is the highest path. But did it come from the right place? I feel like it might be in the backtracking where this is wrong. Feels like it. Feels like it. So this is in get prev k. We just want this guy to say maybe we need to like think about which k value we would have preferred to come from. And is this guy used? Where is he used? He's used... It looks like only in backtracking. Okay. So we can just look at this. We'll look at this one case. And we'll say... we know that these are higher y values, which correspond to smaller k values. Which means that in this case, when we tie on direction, we want to come from the smaller k value. So we have to say here, if we're going backwards, we want the smaller one. And if we're going forwards, we want the bigger one. Maybe. Maybe. Oh, there it is. There it is. Okay. Okay. Uh-huh, yeah. Oh, there's the path. There it is. No. It was close. We almost had it. Okay. So here, he's gonna jump up this way, right? But the problem is probably at this guy. All of this is right so far. So far. Okay, hold on. We're gonna screenshot this because I think we're about to hit the bug. So whatever just happened means that our paths aren't synced anymore. And what is that case? What just fucking failed? So this guy was coming from over here before. But then... Fuck. So it's that we are now on this diagonal like this. Patterns like that make you see black dots in the light. Oh, yeah, I've seen that before. Yeah, I know what you're talking about. So the problem is that we're on this diagonal. And he has basically decided that he wants to come from here instead of from here. Which means that we need to pick so here he's saying that my x value here on the coming from below is smaller than the value coming from the right. And I need to remember, so this is increasing x, this is increasing y, this is negative k, this is positive k. Yes. Yes, okay. So when we are on this diagonal, k is equal to negative 1. It is the resolution of how I got here. Previous k. Previous k. Previous k. So that's related to this. And so it's like almost like this condition. It's something about here. Because we want the equals case. Okay. We'll change this the direction forwards and backwards. Maybe have different conditions here. And so here it's if left is less than right, you do k plus 1, else k minus 1. And here it feels like it's more something along the lines of like if right is less than left. Let's think about this. Let's think about this. Again, we will simplify later. So here, we have... First of all, what are we calling right and left here? Right is larger x, or larger k. So this is right in this scenario, and this is left. So we want to favor left if they're equal. Uh-huh. So if right is less, we want the bigger x number. But if we're going backwards, the right thing is a much smaller x value than the left quote-unquote thing. And in that scenario, we want to go left. So if right is less than left, or it's equal to, we want to favor going right in general, then we go k minus 1, else go k plus 1. Maybe? Who fucking knows? I don't fucking know. Now we're back to this guy trending the wrong way. So this is k2, k4. So he's obviously trending, he's obviously picking the wrong one. Am I fucking high? Positive k down here. Positive k is called right in this world. And sorry, we want the bigger one. We want the bigger one. So if left is greater than or equal to right, pick right. Sorry, pick left. Otherwise, pick right. Which, is that the same fucking condition? I don't know. I don't know. We'll have to do some, like, what the fuck is going on here? Am I fucking high? I'm pretty sure k is increasing. We're going down to the left. When we go down to the left, x is increasing. So this is positive x. This way. That's correct. Positive k. Also correct. Right. Also correct. So in this scenario here, he is seeing that we have a bigger x value here than here, and we're picking the bigger x value. Oh. So we just can't store it. This explains a lot. This explains a lot. This is why in like the linear version of the algorithm we saw, we have to store the y value. Yeah, that explains why in this guy's version, in this guy's implementation, we saw he's storing y instead of x. And now I understand why. Is because there's no way when storing x to encode that you want to store this value come from here in this case and come from here in this case. Because in this case, x is greater, and in this case, x is greater, and it's just like, what the fuck are you supposed to do? It's all making sense now. Somewhat. And this is why it's good, I guess. Well, not good. I mean, this is what I was trying to get to by implementing this myself, is a better understanding of what is happening. Okay, so this approach of our backwards iteration is just like kind of wrong. And if we want to keep using x and y in the same way, if we want like the algorithm that we're using for the forwards pass to be the same one we're using in the backwards pass, it seems like we have to invert which x and y is what x and y is referring to. It seems like we don't have a choice in that matter. So we have two options. One is to duplicate the algorithm for the backwards pass and flip usage of y and x. And the other option is to flip what x and y mean and then keep the same thing, but then when we convert back to normal, like the edit graph, we swap them. I think this is still maybe doable. Let's look at what I've done. Lincoln Park, 2007. What I've done, Lincoln Park. Hell yeah. That was the coolest song of all time when I was however old I was at that point. Can I play it? Is that gonna like copyright strike? Probably. I won't play it. I won't play it. But absolute banger. Okay. So let's look at what I've done. That's how I got onto that tangent. So we kind of want, let's extract from source. He is basically inverting direction based off forwards and backwards. And so if we wanted to also invert, which one, we would kind of have to make two functions here. I wonder if you could do like function like what? Like we'd have, you want to take like a XY position and turn it into like a buffer index position. Fuck! Everything's so hard. Okay. So let's undo all of, can we like undo everything that we've done in terms of direction? Like, let's get crazy. So what have we committed anything today? Today's Monday, so no. So let's just like go and keep any change that we think is useful. So kind of like selection of which algorithm we're using. This is all great. This I think we don't want to keep. Fuck that noise. We probably want to keep the idea of direction. But not change anything related to usage. So fuck that, fuck that. We can keep the print line, but let's keep the old while loop. This is probably relevant. I'm not positive about like the debug backwards pass rendering stuff. We might need an adjustment here, but here they're kind of saying forwards do exactly what you were doing before. Backwards, we're inverting x and y. So there might be like a yx inversion here. So I guess we'll keep this. That seems fine. We won't keep this. This we will keep. The backwards iterator knowing about direction. I'm not convinced we want to keep that. So I'm just going to say, fuck off. We do want to keep that. That was important. This was a bug fix for our unit tests. Fuck you. Okay. Git commit -m. Changes, I think, are good. And then we'll git add -u and we'll say git checkout -b backup. We'll say git commit -m. Changes, I think, might not be good. I'll check out viz again. And now let's see if we compile with that combination, and we don't because in librs line 516 we were constructing the backwards iterator with the forwards mode and cargo check. Probably we were doing that in the visualization, the debug stuff as well. So for 63, yeah, it's here. Okay. Cargo check. Cargo test. Okay, so just want to make sure that like the forwards pass is still working correctly. Great. And if we cargo run our visualization in forwards mode, I just want to make sure that like we're in like a good state before I start like ripping my hair out again. So that's looking good. So he's iterating bottom left to top right, taking paths on the top right, and then when we go backwards, he's going this way, and yeah, he's sticking to the bottom, which is not what we wanted. We want him to go. We actually kind of want him to iterate. Hold on. We want him to iterate this way, bump, 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 and then stick to the right. Okay. Okay. So now, what was the new attempt? Was that we were going to try to invert x and y in the case where we're going backwards. So that means we need to fix this. So here we're going to say let left, right, top, bottom, A, B. These are all the things that we're changing based off of our direction. Okay. So if we are going backwards, we are saying that left and right is top and bottom. Top and bottom are left and right. Oh, wait, is that right? AB is BA. I'm not positive about this anymore, because top and bottom are, like, these might need to be inverted. Like, left might need to be, we might go bottom to top, right to left. But we'll see. We'll see. So left is top, right bottom, top left, right bottom right. Okay, cool. And then direction forwards is just all of the things normally. So self.left, self.right, self.top, self.bottom, A and B. Okay. Now, anywhere we use self dot left and right here, we delete. And now we are indexing into A with X, B with Y, but the meanings of A and B have switched. So we're fine there. And now on the debug info extraction, we just have to invert X and Y here. So we have to say let X, Y is equal to X, Y is equal to Y, X. Maybe. These X and Y come from the trace. I think that's maybe fine. I don't fucking know, man. Oh. That's looking approximately like what I want. Oh, wait. No, it was for a second, but now I'm realizing the diagonals are in the totally wrong spot. So he's still iterating forwards because we did need to invert those directions still when we check for the diagonals. If I was if I worked at a company and I committed whatever the fuck of a monstrosity I'm making right now, my future coworkers would fucking hate me. Holy shit. Hopefully I get to a point where it's cleaned up a little bit before we commit this, because holy shit, whatever I'm doing is like such a disaster. Oh my god. So maybe that extract from source function that we had in the backup, libdiff source lib rs, I think that actually still applies here. I think. We'll find out in a second. So because we've already inverted X and Y, this like inversion of direction applied to that particular source, I think is still fine. Okay. Boom, 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 boom. So these are all coming from the right place now. Yep. So far, so good. This is wrong. But overall, like, I think it's very close. I think maybe the problem is our iteration order. No. Because here we would go boom, boom, boom. Boom, 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 boom. And then here we would notice the diagonal and go shoot to here. Let's run it again. Let's think. Is there something about going bottom left to top right that's affecting... Which way? I'm not sure. So what are we expecting to see here? We're expecting to see that this diagonal It's when he gets to here, it's like, do I come from here or do I come from here? And he has to want to come from here. Oh, it's actually this guy has to want to come from here. Okay. So, have we visited this node already by this point? I can't remember. We would have had to, because the previous diagonal is here. Well... My gut is saying that there might be an effect on iteration order, so I do want to see. So I'm just gonna rev this temporarily, just to see what happens. And then something is fucking being stupid here. Hold on. He definitely doesn't like that. Oh, because I'm only doing it in debug info. So can I do it in step? Oh, I'm so lost. Yeah, so how... Well, let's look at the forwards version again. Forwards. He goes down first, then up. So actually, this is what we expect. Is like we go down first when their axes are inverted. So he should go left first in the backwards pass. So let's look at that again. I don't think that's it. So he goes left here, bum 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 bum, and so it gets a little tricky in this next loop where here he's saying I prefer to come from the right, which makes sense, and here he's also saying I prefer to come from the right, which makes sense. Then here this is where it's strange. Is so this diagonal in this case has not made it like this. In terms of this diagonal, we are the highest X position, which is actually our highest Y position, is here. So that actually does make sense that that's what he would choose. And I guess technically these are the same edit sequence because there's 2 6s in a row here, which is kind of making this a little extra confusing. But he's deleting 5, adding 6, then traversing 6. And in this other version, he was deleting 5, deleting 5, traversing 6, then adding 6. So here, it's like, it's almost the same. Otherwise, is this correct? That is a very, very similar edit graph. I will say that. Like, his final answer is almost identical. It's just this, like, double diagonal thing is not working correctly. So I don't know how convinced I am that this is wrong. This might just be an edge case of the algorithm. I wonder, maybe it would be interesting to try some other sequences. So let's go into diff, our diff visualization. And maybe what we should do is we should be able to pass in sequences. So maybe we'll take in a bunch of... what are we calling our algo? It's I32 is what we're taking right now. So we'll do that. And I guess maybe what we'll do is when somebody passes in the argument A, we'll continually take the next thing while we can convert it. So I think that means that we need to say that let it is it peekable, so that we can, in this case, say while it peek, while let some, we'll just say it peek, map x as to x parse as an i32. And then this is going to become like an option result. But if this fails, we don't actually care. It just means that it's not part of the values that we care about. So we can flatten this. I think it's like iter flatten next or something. And then we can say like while let sum v is equal to this fucking shit show. I think there's probably a better way to do this. We'll say a push v. Let mute a is equal to vec new. And then here we can at the end say a, and for now we'll just say b is vec new. Let's just see if that constructs. Yeah, looking good. Looking good. Okay. And then let's just try printing out A. So we're going to say print line A is this thing, which is A. And then we should be able to say like A 3, 4, 5 top 3 or something, right? Like let's just see what happens there. And here we have to say if we got something, we need to advance the iterator. But if we didn't, then we don't. Okay, so we have A is 3, 4, 5, which is looking very promising. And then if we say like ASDF, he's going to say ASDF is an unexpected argument. That's great. That's perfect. I don't like this, like the whatever the fuck I've done for that flatten thing. So let's look up option in the Rust standard library, and surely there's some, he just has a flattened thing that flattens an option. So maybe we just say we convert this result to an option, and then we can just call flatten without the iterator. And maybe we do like and then we don't have to flatten or call next. And that looks a lot cleaner. And he is still working correctly in terms of failing on ASDF. And 3, 4, 5. Okay, sick. And then so now we just do the same thing for B, which means that this should be like a function. So we can just say like, I don't know, function parse i32 arg list, and he's gonna take in like some iterator parse i32 arg list. This sounds complicated. What's less complicated is if I say let parse i32 arg list as a closure, then I don't have to think about types. So this is gonna be like this, yep. And here we're gonna say output is a something. We're gonna say output.push, yep. And then here we can say parse i32 arg list with a mute a. And here we can just say this is a mute vec i32. But here we have to pass in it as well. Because we can't borrow it twice. Oh, but he needs to know the type. Fuck, we're back at the same thing. So what is the type of IT here? Maybe we'll just fucking slam it. This is a peekable IT, yeah, so just say peekable IT. This is like probably stood iter peekable or something, which needs mute on it, and probably needs to be a reference to a mutable thing or something, because we need to change it in outer scope. Fuck you, Rust. Okay. B, 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 A, B, A, B, B. Is this riveting content? Is me just saying the letter B over and over again? I'm sure we fucking love it. Okay, and so now instead of A and B being like this, we're just gonna pass in args like this. Boom, 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 boom. And then A and B don't come in from externally. They are part of the argument, so we're just gonna say args.a.len, args.b.len. I guess we can just say that A and B are now not sliced shared reference things, they're just vec i32s on both of these, which I think should keep very similar API compatibility. I'm going to say A is equal to args.a, and B is equal to args.b. Hopefully all of this stuff just compiles the same, and we have to do this at the top. Slap it up here. Womp womp, and now it looks like things are compiling again. So we wanted to say, let's just try what happens if we do A is equal to 345. Fuck. B is equal to 3. Okay, so that's looking like it kind of worked to some extent. Let's not pass in backwards, and let's add like 3333 or something. I don't know. It's just like, that's looking like it's working, which is pretty sick. And now let's try the backwards version of this and just see what happens. There's a bug here for sure. He's starting off to the edge. Like, what the fuck? What the fuck? What the fuck? This is coming from probably the backwards walking debug info. So here, it looked like, in that brief look, it looked like the shape was right. Right, you can see this diagonal here. I changed my mind. This is just fucked. Is it because we're not, like, did we not finish the backwards stuff? What, didn't we look at this with these strings and think it made sense? So can we like copy paste this and cargo run, edit this guy, paste this, delete all the commas. Okay, this is A, and this is B, so it's delete to here. B is delete all the commas, because our argument parser doesn't expect them. Like, didn't we think this looked okay? Yeah, how come this is fine? What changed? Because this is tracing the path, like, totally reasonably. Okay. So, what did we do differently here? Like, okay, first of all, let's put this in a script so I don't lose it. So, we'll just say, this goes into, like, I don't know, old, like, original experiment.sh. Okay, which is wonderful. Okay, and then we can just start, like, going ham on it. So let's just say Shove a bunch of 3s in there. Fuck. Gotta be really fucking careful there. I just overwrote the script. That's funny. Next. Next. Okay, this is working fine too. And this is kind of doing what we expect where... Wait, is it? This actually, I changed my mind. I think this is not what I expect. So let's remember this. Let's remember this. And if we invert this, if we invert this and invert A and B, so we just say this is B and this is A, and we go forwards. Is this the same? Oh, fuck, we need to invert the direction of, this needs to be, B needs to be 8, 7, 6, 5, 4, 3, 2, 1. Not the other way around. Right, so now this looks the same. Blah, 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 blah. Oh, yeah. Yeah, okay, that looks the same. Right? Just let me spam next a few times. My wrist is gonna fucking hurt. Hold on. How do we make it so that we can see both of these at the same time? There we go. That's the same, right? If we, like, resize this so that it kind of matches the shape better. I think that's the same. That's mirrored over the diagonal. Yeah, it is. That's gotta be the fucking same. That's the same. Okay. So assuming that our forwards pass is working, then our backwards pass is also working in this scenario. This is one scenario. Now, let's try shrinking... we'll go back to this case, and we'll try shrinking B a little bit. So this is where the bug is happening. So it's probably related to A and B being the same size, probably. There's probably just like some index that's using X when it should be using Y. Yeah, there's a bug there for sure. Okay. Fuck! Why can't it ever just work? Fuck me, man. Okay. X, A, Y, B. Here we swap A and B if we're going backwards, so X should be related to Y, B should be... Okay, but it's also more... It's the conversion. It's the conversion from DK to XY for backwards conversion. Yes, it's the backwards conversion. So here we go. Let me extract an X value, which is actually the Y value that I stored in the trace. And I need to offset it by, this is probably... Well, here left and top are both 0 in our scenario, so it's not this. This is 0, 0. X... it's this. So I think in the backwards pass, it should be this way. Because X is related to B. And so this is just Y. Yeah. I think that's it. Okay. Yeah. Okay. So now we can reduce... Oh, fuck off. Now we can just reduce the B's even more. Less 3s, please. Okay. I think that's behaving correctly. By some definition of correctly. Can we go back to the original experiment? Like, this is what... is this what we thought should happen? It's close. And so why did we add this, like, runtime thing? It's because we were worried about this case. And so I wanted to see more of this, like, vertical... diagonal thing, and I wanted to maybe try spacing them out more. Yeah, that's what I want to try. So I wanted to, like, maybe move this second 6 down a little bit. So cat original experiment. So we'll take this guy. And I wanted to maybe put this 6 here or something, just to see what happens. So now we have like the same double thing, and now we greedily jump here and then jump up here, and then we... So this edit sequence now becomes... This is the one you want. And if we run it forwards... Nice. If we run it forwards, it's the same. So that's good. So it could just be that when there are 2 back-to-back of the same, like the same match, we might just get like a little bit of an edge case there. But I was worried that like the sequence here would change, but it doesn't look like it is. Because if you go right here and then go down, you miss this diagonal. So you miss this diagonal. Right. So you need the same amount of diagonals. But what if... Yeah, I think that's fine. You could put the second diagonal like here and here or something. No. Yeah, I think it's fine. Let's just do one more check of limiting the like top and bottom. So top 3, bottom 5, left 3, right 5 or something. And we'll do this in forwards mode. So that's this, and we should see boom, 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 chilling. And if we do it in backwards mode, do we like iterate the right spot? Maybe. Our visualization's just drawing nothing of fucking value. But I think that's probably a visualization bug. That's probably related to this, so... This backwards thing has to be like related to the width. So we need to do like b.len minus self bottom, and I think we'll see. And this is self dot right, I think. Close. -1. Maybe. I guess there's 2 potential places where we're off by 1 here. It's like in the actual iteration or in the visualization, so we can just check by the... But the diagonals are lining up, so I'm pretty confident it's there. Yeah. Okay. Okay. Let's try a slightly different box just to make sure that we're like... you know, we're not getting like one shitty example. 6 top 2 or something. I just want to like see. No, okay, so we got lucky there with yeah, something here is just fucking stupid. Whatever we're doing, fucking stupid. So let's look at this again. So a dot length x position is the b length minus self bottom is going to be where he starts. Okay, a length minus self right I think is still fine because a is related to width, b is related to height, but we have to invert x and y, so x is height. Yeah, that seems reasonable to me. But clearly it's not, right? Here, we need to, because we're adjusting... I think here we only do this if we're going forwards. That's my guess. That's my guess. Without thinking at all. As you do, you know? As one does, you just copy paste randomly, don't think, and just hope for the best. And that's clearly not the fucking best. What the fuck is happening? Obviously that's wrong. Because we didn't think. We have to fucking think. Okay, so we're trying to get a global XY out of these guys. So here, we are saying, hey, what is the length of this guy? Now subtract the bottom and the right. So x0 should if x is 0 when it comes in, we take, it's not this, it's the fucking, we just fuck. It's this. That looks more right. Because if we're at the bottom right, if x is 0, we want to be at the bottom right. And then we don't have that -1 problem anymore. Does that make more sense? Maybe. We'll find out. That seems correct to me so far. And then let's go forwards, just to make sure. Yep. And then, was that the same path, by the way? This was left, up, left. We'll just see. Yeah, left, up, left. Same path. We're chilling. Okay. So let's try moving the box one more time just to make sure that we didn't like overfit. Seems fine. Yeah, that looks right. So we've got backwards iteration who is taking the same path for the most part, right? We've got a couple cases. We saw one case where it was taking a very slightly different path that I think had no effect. Jesus, and that took an hour 50. So I thought that we would get through all of this a lot faster, but we really struggled with the backwards iteration. But I think that was, I think I prefer to have struggled with it, because I think that if I had tried to blindly just do what the guy said in the blog, I don't know if I would have like had as good of a feel for it, right? You kind of gain intuition by making the mistakes. He says to justify making mistakes. But yeah, I think I'm pretty happy with that. I would have liked to have made more progress, but I think that we're in a pretty good spot. So I'm gonna call it there. We're just under the 2-hour mark. If you like what you saw, I stream most days at around 1 or 2 o'clock Pacific time for a couple hours. So if you're online in, between 1 and 4, you could swing by, see if we're online, see if we're doing something fun. Right now we're working on this Git GUI and therefore this diff algorithm. Other projects that are in flight are like, I would like to get back to the terminal emulator that we're working on. Someday I should probably get back on working on that operating system, but I don't really see that happening in the near future. We've been working on kind of a variety of things. There's like web dev, there's 3D geometry, there's neural networks, operating systems, virtual file systems, diff algorithms, Git GUIs, whatever the fuck I feel like working on. That's what gets done. So if you're curious about any of those other projects, there's a YouTube link in the Twitch description that has playlists for all of them, as well as a GitHub link in the Twitch description where you can check out the code. If you're on YouTube, there should be a Twitch link in the YouTube description where you could swing by, say hi if you feel like it. I think that's it. We'll be back on tomorrow to continue on with this. I think hopefully we can make some meaningful progress based on finding the points where the backwards and forwards algorithms meet. Hopefully, we'll see. So that's the plan for tomorrow. Thanks for watching, guys, and I'll catch you on the next one. Bye!